All right. What's going on, pre-calc? For those of you who don't know me, because I only have one section of pre-calc this year, I'm Mr. Smith. Pre-calc is one of my favorite classes to teach, and one thing I'm doing this year is I'm going to make a short video every Monday night, and that's going to be our homework. It's just to watch the video. And then when we come in Tuesday, we will already have kind of watched the lesson, and then we'll be able to just get after it in class and start practicing rather than do a lecture that day. A little bit of a flipped classroom type thing. So I know it's going to be, I can promise you that it's going to be a short for a couple reasons. One, I don't want you spending forever on homework. I know you all are busy. And two, I love Screencast-O-Matic, which you can see right here, and I'm too cheap to pay for the full version, so I got to keep my videos under 15 minutes. So 1 minute down, 14 to go for this video. My goal of this video is to help you get ready for the quiz tomorrow. And I'm going to pretend like I'm a student here, and that's why I purposely don't have anything pulled up, is because I'm going to show you also through this video kind of a way to study it for future tests and quizzes. So I'm going to do a problem from each method of factoring. And so that's the key. You got to know the 4 methods of factoring. So I'm hoping you could rattle those off quickly. But let's start with a good old factor using greatest common factor. That's one. And so let's type that in. And then we could do this. We could say worksheet. Just showing you things that you can use to help. Find the greatest common factor with polynomials. Let's see how that works. Boom. Let's just pick one. See, I went down to kind of the harder level ones. Booyah. Let's do this one. Looks kind of tricky. And now I'm going to go just full screen snip. We'll just write straight on the screen. So 20y to the 4th minus 15y to the 3rd plus 30y squared. They all have a GCF of y squared, because this one has 4, 3, 2, so they at least have 2. And then all these numbers look like the greatest common factor of 5. So I'm going to pull out a 5 and a y squared. And so what is that going to leave behind? It's like reverse distributive property, right? So what do we got here? We got 5 times 4, and then we're missing a y squared. We got 5 times 3, and we're missing a y. And we got 5 times 6. So I'm done factoring using GCF, but I have a feeling I might need to break this one down more using one of our other methods, which often happens, so it's okay that I'm doing that for this example. So let's see. It's 3 terms, so it's probably going to be trial and error. And just bring that one down. Are there factors of 4 and 6 that could give me 3 in the middle? We start messing around. 4 times 2 would be 6. Yeah, I think so. Let's do 4y here, which would make 1y go there. And let's put a 2 here. Oh no, that's 8, my bad. I said 4 times 2 is 6. 4 plus 2 is 6. 4 times 8. So that's 8. And 3, that would not work. What if we did 12 and 2? That would not work. Okay, so let's do 2 and 2. This is called guess and check for a reason, gang. And just seeing these patterns is going to make you a much better mathematician. So we're trying to get a 3. So what if we did a 3, which is a 6, and a 2? Nope. 2 and 3. Yeah. I don't think that that can go any farther. So I think we are done right here. You always want to check to make sure it could go farther. And granted, I would probably check a little longer if I had more time, but I think that we're done. So GCF method, you always do that method first. Jot that down for the quiz tomorrow. Every problem you look at, if you can take a GCF out of it, do it, because you're going to make your life a lot easier. I'm nervous that it's not recording my sound because it's got the little mute button here. If I make this whole video and it doesn't record the sound, I'm gonna be hot. All right, let's just keep rolling. So that's the first method. Second method, let's go difference of squares worksheet. So we've done all of these, but let's just click this one. Yeah, these are easy, but I like to scroll to the bottom and get one that's a little more tricky. Like number 20. It's like, wait a minute. Number 20 isn't perfect squares. 54 and 6 aren't a perfect square. But wait, 6 can go into both of those. So if I pull out a 6, this is now a 9v squared minus a u squared. And believe it or not, this is a perfect square and this is a perfect square. So we officially have the difference, aka the subtraction sign, between two perfect squares. And how do we break that down, like we've been doing these last few days? Is you take the square root of each of those and you put it into its separate parentheses. So 9v squared, when you square root that, something times something, you're going to get 3v into each of your spots. And when you square root just a u squared, you get u and u. And then we're going to have 1 plus and 1 minus. And so this would be our answer right there. If you don't believe me, I don't have enough time to do it, but you can FOIL that out and you will get this. And then if you distributed that 6 back through, you'd get this. So you can pause this video and go back and look. Like, how do I know? It's 2 squares with a minus, but those weren't perfect. But wait, I pulled out the GCF first, and that was the eureka moment. Okay, you can't be a robot. I'm going to say that a lot this year. You got to learn stuff, not just surface level. You got to be able to apply it in slightly different scenarios. That's going to get you over the hump in this class, okay? So that is the difference of two squares method. Now let's do the one that you've probably done the most, which is trial and error, factoring worksheet, or guess and check is what it's called often. Let's just see if this one has it. And I'm doing this on purpose, not to waste time, but to show you, like, you can, Google is your friend, guys. Yeah, beautiful. I could pick any of these. Let's just pick this one. How do we know this is trial and error? Been asking you that question all week. It's because it's got 3 terms. 1, 2, 3. We can see it's a trinomial. It's a quadratic. We're going to talk more about that second semester, but we need to know how to break this thing down. So we go boom, 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 boom. 2 sets of parentheses. 2n squared has to be broken down. So 2n and n. That's our only option. 9, we could go 1 and 9 or 3 and 3. That's where the guess and check comes into play. You pick factors of 9. So I think I'm going to probably do a 3 here and a 3. Because if we do a quick check, 2n times 3 is 6n, and 3 times n is 3n. And yes, we'll be able to use our negatives to make that work. So that was a quick check. You don't have to FOIL it all the way out to check. You can just do a... oh, that scared me. You can just do a quick outside term, inside term. So we need this to be a positive 3. So I want 2n times 3 to be positive 6. And then minus. And just for the sake of this problem, I will check it and show you. 2n times n, 2n squared. 2n times 3 is 6n. Negative 3 times n is negative 3n. Negative 3 times 3 is negative 9. This becomes 2n squared. 6n minus 3n minus 9. Booyah, booyah. All right. That's guess and check or trial and error. Remember, if you can take a GCF out, do it. Like if that wasn't a 2, if that was a 6, then I would have pulled out a 3. Because 6 and 3 and 9 all share a 3. So I would have broken that down with a GCF first, if I could. All right, uno más. The one that students forget the most, grouping. Factoring by grouping worksheet. And even if you do a typo and do groupoing, it'll help you out. Google's smart. Let's just do this one. And this will be our last example. And then I'll just remind you of the 4 methods, but you'll be ready to roll. How do we know that's grouping? Well, I'm hoping it's automatic. It's 4 terms, 1, 2, 3, 4. And grouping is almost like a double GCF. I'm going to take a GCF out of these two. Then I'm going to take a GCF out of these two. So 12n cubed, 4n squared, they share a 4n squared. That leaves behind a 3n plus 1. Well, you know, there's already a 3n plus 1, so I don't even have to do anything to that. That was kind of lucky, I'm not going to lie. But I'm glad we did this, because this might be a little weird, because what I've been telling you is, do you see how this, I'm going to underline it in blue, this is now your first term, and this is now your second term. Both of those share a 3n plus 1. They have that in common. So we're going to pull that out. And that's going to be huge later in the semester. You can factor out numbers, like we pulled out a 4n squared here, but you can also pull out entire factors that they share. So a key thing to note is that there's an imaginary 1 sitting right there, and that's important. Because what I'm going to do is I see that both of these terms, this is term number 1, this is term number 2, both of those have a 3n plus 1, so I pull that out. And then what's left over? Well, 3n plus 1 times 4n squared would take care of the first term, and then 3n plus 1 times 1 would take care of the second term. So this is my answer here. Okay, another way to do it, which is the shortcut way, but I don't want to make robots, I want to make people who understand this stuff, is that what is on the outside, the 4n squared and the 1, it goes here in one of your parentheses, and then the thing that they have in common is the other one. So think of grouping as a double greatest common factor. Okay? One more tip, because I just looked at what was on the quiz, and I just want to remind you, let's do it with, say, difference of squares worksheet. There is a slight difference if it says to solve. So if this right here was 4n squared minus 49 equals 0, you would not just do 2n minus 7, 2n plus 7. That is factored correctly, but that is incomplete. You have not solved this yet, right? So what you'd have to do is you take each of these factors, 2n minus 7, set that equal to 0, and actually solve. N equals 7 halves. And then you do it for both. So 2n plus 7 equals 0. N equals negative 7 halves. So you actually solve for the variable when you see an equal sign. Makes a big difference. All right. I think that's all the tips that I got for you. Hopefully you watched this whole video. Go back, and if you are worried about the quiz, just know your 4 methods. Know when you're supposed to look for them, how they each operate, what the difference is between solving, and go look for some other examples, just like I did on Google, and practice to your heart's content. Thanks for sticking around and watching. Reach out to myself or Mr. Okposio on campus. Maybe you can find us in the morning before the quiz if you got any questions. Love y'all. Peace.